Yeah, so we're very happy to deliver this tutorial. Well, in this case, only remotely, in the tutorial Trustworthy Algorithmic Ranking Systems. So you already seen me, of course, Markus Schädel. I'm delivering this tutorial really together with Emilia Gomez and Elisabeth Lex. Yeah, so a quick introduction about ourselves. I'm a professor at Johannes Kepler University in Linz, in the center of Europe in Austria. I'm a head of the Multimedia Mining and Search Group at the Institute of Computational Perception, and I'm also affiliated with the Linz Institute of Technologies, in particular the iLab, where we work on human-centered artificial intelligence. So for all of us, you have some links, of course, personal ones, and to the lab. My interests are, well, obviously foremost on algorithmic ranking systems. So we'll define a bit more what we mean by that. So it's actually foremost recommender systems, retrieval systems like search engines, and related topics like user modeling, machine learning from an applied perspective, NLP, multimedia, music, and text and web mining. I think Emilia and Elisabeth.
Hello, good morning. Hello. Can you hear me well? Yes, right. Okay, hello, good morning. Very happy to be here. It's very early morning in Europe, so we are still up. I hope you are having a good tutorial day. My name is Emilia Gomez. I am leading the research lab at the European Commission Joint Research Center. This is a research center that is part of the European Commission. And I'm also guest professor at Universitat Pompeu Fabra in Barcelona. I have a technical background and I have been working a lot on music information retrieval. And now I'm more focusing since some years now on studying the social and ethical impact of information retrieval and recommender systems as part of my job in the commission. So very happy to be contributing to this tutorial.
Good to have you here. Oops, sorry. Spoiling.
Hello, everybody. I'm very happy to give this tutorial with my colleagues Markus and Emilia. I'm very sorry that I miss the conference in person in Singapore, but I hope you have a great time and enjoy the conference and hopefully also our tutorial. I'm an associate professor at Graz University of Technology in Austria. And there I'm also head of the Recommender Systems and Social Computing Lab, which is located at the Institute of Interactive Systems and Data Science. If you want to find out more about the topics of our lab, then here is a link to our lab website. So it has, on the one hand, descriptions of papers, but also like code to all the implementations that we do, because we really believe in like making research reproducible. In terms of interests, I think, all my colleagues, my fellow colleagues and I, we share similar interests. So I'm very interested in user modeling and recommender systems, of course. There I specifically focus on leveraging also models from other disciplines in order to design algorithms such as psychology or the social sciences in general. I'm very much invested in information retrieval and also in natural language processing, whereas we work on using NLP technologies in order to extract content bias of information online. And I also work a lot in the field of computational social science, where the idea is really to leverage computational methods in order to study interesting social science related questions. You can find the contact information for me at the bottom of this slide, and I'm very happy also to answer any questions that might come up afterwards.
So now we want to know about you, and since we wanted much to make this tutorial as interactive as possible, of course. So it will be a little bit less maybe due to no one being there, but I still hope that that you can share your opinions, views on Twitter, for instance, using the hashtag #Wisdom23Trustworthy. And as an additional means of communication, we created slider, actually, polls, which will be sprinkled in through the entire tutorial to make things just more interesting, interactive, and has been appreciated already quite a lot. So here you can find the QR code already. So if you want to take a picture of that, I'll just leave the slide for a couple of seconds more. I just uploaded the slides and posted the tutorial slides and posted the link to the chat here. And maybe meanwhile, while I'm speaking, Liz, you could maybe also upload them to this to the original location, because I had to upload them somewhere else where I have access to, of course. So they are also there where it's indicated on over. Good. I guess I hope everyone who wanted it got it. So what we'll be talking about during the next, 3 hours or 3.5 hours. So just to give you a bit of an overview about our agenda, we're right in the middle of the introduction already, of course. Now you know who we are. And we'll start with a brief introduction into the topic, of course, of algorithmic ranking systems, why they are relevant and why it's relevant to consider them in a more trustworthy or ethical framework, so to say. So taking a broader picture and positioning the ranking systems in the context of trustworthy AI, Emilia will give you an overview of trustworthy AI, particular key requirements, and also tell about how the ethical principles can be kind of converted or installed into regulations. And we'll do this with a particular perspective on the European Union, but we'll also discuss other initiatives in other parts of the world as part of the introduction. But since the European Union has been at the forefront of regulating AI and providing respective guidelines and policies, we'll focus on that. Okay. Then I'll continue with the part on fairness, bias, and non-discriminations. We'll talk about different categories and kinds of biases, how they relate to fair behavior of ranking systems, and how they might lead, unfortunately, to discrimination of certain groups or users. And then the main core additional parts here will be the question or discussion of how we can measure biases and fairness and algorithms to get rid of unwanted biases and hopefully improving fairness of such systems thereby. Then Elizabeth will talk about transparency aspects, in particular different categories of transparencies, like explainability and justification, traceability and auditability, and also documentation. And then we'll finally end with what we believe are the most pressing open challenges that should be addressed and receive maybe more attention as they currently do. So we make available, of course, the tutorial slides here. So the first link is currently updated by Elizabeth. The second one is actually the link where I uploaded the slides. So please use for now the second one here. So the .cp JQAT tutorials wisdom 2023 _TARS. So trustworthy algorithmic ranking systems. Good. Let's start with an introduction. What do we mean by algorithmic ranking systems? Well, some of that might be obvious anyways, but basically we consider all systems that basically take as input some information from the user, like a query, for instance, in a search engine or retrieval system, or some kind of interactions between the user and a list or a set of potentially large set of items, like in the recommender systems, and produce as output a ranked list of such items like web documents or movies or music songs. So this is what we basically consider such a ranking system, just to set the scope. You all know typical examples, of course, so the different domains in which search engines and recommender systems are adopted, like in e-commerce, for product, search for music, I already mentioned that, on different social media platforms, online social networks, like Twitter, Instagram, and so on, Facebook, for movies or TV series, in travel, and also in jobs. And of course, kind of the questions of trustworthiness and biases might be considered of different importance, so to say, for the different domains. Like in the entertainment domain, they might not seem that important, but are still important for when you consider, for instance, exposure of artists or from a creator side, so the people who create the content. On the job side, for instance, this is very important, obviously. So lost opportunities due to some bad recommendations for particular user groups, just to give an example. But we'll come back to that later on. What is important to notice also that kind of the view or the level of integration in our society of such systems has changed dramatically over the last couple of years. So originally, recommender systems, retrieval systems have been considered basically human decision support systems to help us individuals making decisions, or also sometimes systems to just search for information access systems or information seeking tools purely. But due to the nowadays very deep integration into all of our societies, we think that they have to be considered more as socio-technical systems, in fact, because nowadays they are really deeply rooted in our society. They control, create, or also, well, limit exposure of, for instance, content creators to reach their audience, and also, of course, to gain access to markets, for instance. They strongly influence and shape our opinions. Meanwhile, of course, just think of, I don't know, a news platform, for instance, where you're recommended certain pieces of news, others you are not recommended. So you'll create your opinion just based on the things you see, obviously, and not on the things you do not see. So we can say they also strongly influence, meanwhile, our behavior. Again, here, a couple of domains, of course, in particular, information, jobs are important. And they also, of course, shape or control the opportunities we could have. So just as an example here, because they, to highlight that they also strongly raise ethical questions, that if you have, for instance, some, well, high-level AI system, which would be a recommender system, for instance, in our case, and you have different users, then it is still the case that many systems, for instance, might rather recommend to female users typical female jobs or jobs that are stereotypical, taken by females, that are often lower paid than alternative jobs, and so on. So there exist a couple of studies on that. So now digging a little bit deeper into the implications of this, so kind of considering such systems as socio-technical systems rather than purely computer science, or systems created by computer science and having only them as a stakeholder. This really calls for a multidisciplinary perspective of such algorithms. So actually, the main message here is that algorithmic ranking systems, or the trustworthiness in particular of such systems, is certainly not only a technical problem. So we need a multidisciplinary perspective to take on that, and this involves, of course, expertise from ethics, legal aspects, also sociological aspects, or psychology, for instance, of how do users interact with the system, what are their motivations, and so on. And this actually, of course, has also resulted, realizing that it's not only a technical solution, so to say, have resulted in a lot of policies and regulations. We'll dig deeper, or Emilia will actually dig deeper into the European perspective, so to say. So I'll just mention here that there are a lot of different EU regulations and laws that address this topic, like almost EU Charter of Fundamental Rights when it comes to non-discrimination, for instance. But in particular, in the last few years, a lot of other guidelines and policies and acts have been installed, like ethical principles for trustworthy AI. More recently, the Digital Services Act, for instance, as well. But it's not only in Europe that people start, or actually policymakers start, trying to regulate AI. Also in China, such initiatives exist. So, for instance, by the Cyberspace Administration of China, that actually focused on proposing some rules to the deployment and use of online algorithms, in particular those that shape the public opinion. And with China Academy of Information and Communication Technologies, which focus on testing and certifying trustworthy AI systems. And then also, of course, the Ministry of Science and Technology issued some guidelines to establish ethical AI principles. In the US, obviously, also some things and initiatives going on. So on the national level, Congress has adopted the Artificial Intelligence Initiative Act. But foremost, there are country-specific regulations or guidelines. So for instance, in California, it's automatic decision systems for employment and housing have been regulated recently, and also in some other countries, but there is rather little on the national level in the US. Yeah, the White House has also released a draft guidance for regulation of AI applications. So now I give the word to Emilia, who will tell us more about trustworthy AI.
Thanks, Marco. Should I share myself the screen?
So yeah, it's probably better. Yeah. Yeah. I'll stop sharing.
Yeah, let me see. I think you can see it, right? Okay, so thanks a lot. I'm trying to wake up. It's a bit early, so trying to have some energy for introducing a little bit to the trustworthy AI domain. We selected this idea of trustworthy AI because it covers a little bit all the ethical issues that we will be addressing today. We will be focusing later more on the fairness domain and also transparency, which for us are the two principles that have been most studied also in the literature. But here we wanted to give an overview of what or ethical considerations and requirements that have been studied, and we focus on this idea of trustworthy AI, which has a European focus, but I will explain how this also has been treated in, for instance, by UNESCO worldwide. So, of course, each culture and each country is trying to adapt or is adapting those to their particular context. So this is more or less the definition of trustworthy. It's like something that people can trust. So it's really subjective, and you will see also that some of these ethical requirements and concepts such as fairness and transparency are a little bit subjective. So it really depends on the context and the culture, so we will see that, but it gives us an idea of something like user-centric, so the user can trust a system. So this is a little bit to ensure that people can just use this and systems and are somehow built for public good. So as Marco said, we are going through a paradigm change in the way we check a system, and particularly in my research, I've been very system-oriented at the beginning, trying to see information retrieval somehow as, okay, we extract and inference meaningful information from large collections. So this is like the definition that we always use. And then the idea of what is meaningful is reflected in some metrics or some evaluation strategies of the system. And we are now in this ethical or social impact field, we are trying to see system as socio-technical systems. So not only focusing on the system itself, but also how it interacts with the social system. So the business processes, the organization, also the context of use. So for instance, we have worked a lot into this idea of use case, trying to, and this is an example of a paper that I contributed to, where we try to see systems in their context. For instance, we try to see the context of use of a system. This is based on the UML standard. And then you see the system, but also considering, for instance, the context of use or the intended purpose of the system, the application area, who will be impacted, and so on and so on. So the idea we want to give here is that it's not only, and sometimes as developers, we tend to focus a lot on the algorithm, but in this field, we need to look at the context where this algorithm will be deployed and used, and the impact they will have. This is an example of an effective user recommender system, and this is some aspects we have been reflected, for instance, in this work, including the misuse of systems. So it's important that algorithm developers, of course, they are somehow very, very far from the application, but it's important then that we reflect on the potential impact that our algorithm will have on people and society. So this is a little bit the concept of trustworthy AI, to consider an algorithmic system in its particular context and try to analyze the impact. So the ethics guidelines for trustworthy AI were proposed in 2019. It was proposed by a group of people that were appointed by the European Commission. So that's why it's called independent high-level expert group. So it's not a part of the government, but it's more like people from academia or from industry, from civil society. They were also from Europe and from other countries, and then they were trying to see how AI, or with aspects of artificial intelligence, and artificial intelligence here is considered as a broader area, of course, than information retrieval system. And there's maybe some discussion about what is artificial intelligence and what is an algorithmic system. But here we will just try to apply to the particular concept of or context of this conference. So in these ethics guidelines, this group of experts mentioned that the need to have systems that are lawful. So first, they respect the laws that are into place and also the regulations. Up to that moment, there was no law that was specifically designed to deal with those systems. So this point is a little bit weak in this sense. But for instance, if you check other laws, such as discrimination law, for instance, it should be also respected by those kind of systems. So we can really transpose laws to this field. Then the second point is like ethical, respecting ethical principles and value. And of course, this is what will be the focus of today. And then also the idea of robust. So systems should also be robust from a technical perspective to avoid harm that is unintentional, for instance. So from these three kind of principle, the group defined those 7 requirements for trustworthy AI. So these are requirements that goes from very concrete to very broad, and we will try to go through over the 7 requirements, and they should be assessed and addressed during the system lifecycle. So from the design phase to the deployment and monitoring. So this is the idea. We need to consider those 7 requirements. So today I wanted to go through the different requirements. Of course, then later Marcus will specifically talk about fairness and bias. So in the second part, and also Liz will focus on transparency. So 4th and 5th. So I will try to go a little bit to each of them, and then I see this more as a discussion. So I put some questions in Slido so that also you can engage in the discussion. As you may see, these are very, very broad topics, so it's difficult in this tutorial to give much specific details, but we will try to cover all the 7 requirements. So the first one, of course, is called human agency and oversight. There have been many definitions of what agency is, and also the idea of oversight is also very broad. But this is, I put here the description of the principles, some related topics of research, and also some examples. For instance, this ethical requirement mentions that the systems that we develop should really empower human beings. So the idea of empower is that they should support human beings. This is maybe the goal that we all have in mind when developing information retrieval tools. For instance, in my research I have been doing on music, you always think, okay, this will empower people to listen to music and to discover new music. So this is the ultimate goal of systems. And then it should allow people to make informed decisions. This is already more difficult to assess, that those systems really inform people to make decisions. And so it becomes a little bit more demanding and maybe a little bit different from the way we evaluate systems, because we don't evaluate much how people make decisions. And then it says also systems should foster fundamental rights. And this is, again, something maybe as developers we don't look at this. So this introduced new requirements when we think about system, we evaluate it, which should be human-centric. And this is the idea of human-centric AI, and see not only how systems work, but also how systems support people. These requirements say that at the same time, there should be mechanisms to really control the system. This is the idea of agency, that humans should control the system and oversight them. And there have been a lot of work on the field of human-computer interaction, but it's sometimes not very much integrated into the research community, for instance, of information retrieval. So I put here some related topics of research, of course, that have been around in the field, such as how do we assess the user interfaces that we have in those kind of retrieval systems, and how do we assess the idea of decisions and impact on behavior, as Marcos mentioned. Then there are also related topics on how to reverse system outputs, how to control the system outputs. And finally, there's some topics related to which expertise that do people need to operate this system. Depending on the context, there might be some expertise needed, and how to also evaluate its correct operation. I put here just an example of one study I recently read by Mozilla Foundation, and on the YouTube's ineffective user controls. I mean, the idea is just how we ensure that really the user behavior or the user input to the system, like implicit or explicit, is really changing the recommender system or the ranking system. So just a small reflection, and then we can try a little bit the Slido pool. In your view, is twice the text, but which are relevant human oversight mechanisms, for instance, for a web search engine? I mean, which are the maybe tools or mechanisms that you have developed or that you have considered in your work to allow the user to control the system? Or if you haven't worked on this, which are the relevant mechanisms that you think should be implemented? And I put here the example of a web search engine that might be very familiar to many of you. So I'm not sure if you can try to reply, and then we'll reflect a bit on these questions together. Okay, control over own data. This is very interesting. This is one of the issues, mostly also related to privacy, that we will discuss. But of course, it's important to of course know and which data is asked to people, and also how they can control it. Sometimes when we we work with user modeling. We have some implicit and explicit data, and sometimes for the implicit one, it's difficult to have a control. I don't know if this works because I don't see many input from people. I wonder, Marcus, if this works, or if should I will continue in any case.
Yes, it works, at least for me.
Okay, so I'm not sure if for people in the room.
I just scanned in the QR code through my smartphone.
Yeah.
Yes, we can hear you. Please continue. We can hear you.
Okay, but do you know if the Slido link works for people in the audience? Can anyone let me know, or if this works, or you have any trouble in accessing that? Okay, I will continue, but if yeah.
Sorry, I think there's a problem.
Okay.
I think the poll closed already.
Okay, let me check. Because maybe no setting. I think it's open.
No, now it closed. Maybe you have to go one slide back.
Okay. Sorry.
Because I think it automatically opens and then closes again.
Okay, now it works.
When you show results.
Sorry.
Yeah.
Yeah, try to
if you proceed one slide, then it automatically closes and show the results.
Okay,
which is a bit annoying.
Now I'm controlling here also in my other screen. So let's see.
It's open again.
Okay, so if someone wants to give feedback, otherwise we can also skip to the next one, and then we can. I don't want to make waste a lot of time here. Yeah, privacy. Okay, first, thanks a lot. Someone to put something. Yeah, we were trying, as we are not there, and luckily, because I was being in Singapore, we wanted to give to make a little bit of interaction. But yeah, we will see privacy and control over data is one of the aspects and one of the requirements. I also think about how you can maybe select when you maybe select some content or click some content. Of course, this is somehow a way to give feedback to the system. So any data we can have from the user is needed. So I see there is a lot of interest, of course, and a lot of stress here from your side on the privacy issue. Okay, now we see more like for ads recommendation, cookies usage, ability to delete your data privacy. But in addition of controlling your data, you need also to control the system, how it behaves, So we should provide also the users ways to change the behavior of the system according to their needs and also their intention to use the system. So let me just skip to the next slide with the second requirement. So of course, human oversight is very broad and is related to human-computer interaction. The second one is much more concrete, and this is maybe the one that we have probably spent more effort in our community, which is technical robustness and safety. And of course, this is not information retrieval. It's not a very, for instance, it's not a domain where we need a lot of safety, for instance, compared to other domains such as robotics or automated vehicles, where safety is the key requirement. Here, maybe our community has not focused so much on technical robustness and safety, but this requirement is described as the need to be resilient and secure. So the idea is that in this requirement system needs to be safe and ensure a back plan in case something goes wrong. Of course, this is maybe more relevant for critical scenarios. For instance, when your information retrieval system is used for infrastructure or for supporting a critical infrastructure, so-called. But there's also in this requirement the idea of accuracy as one of the needs and reliability. And of course, in the field, there has been a lot of work on measuring accuracy. This is the main objective we are trying to optimize. But also there has been some work on robustness tests for algorithms, tests for maybe in unintended, for instance, noise in the data, or intended errors, attacks. And here this links a bit with cybersecurity and the need to test our system against maybe intended attacks that might change its behavior. So there's also related to considering edge cases, for instance, and also to make our system maybe reproducible, although not for a safest system or for more secure, but also in order to be able to test it wider. So some considerations in the context of this field. Sometimes the evaluation metrics, of course, vary a lot for accuracy, and this depends really on the use that we make of the system. Sometimes we carried out robustness tests in the evaluation of a system, but they are not widely applied, so it's not something that we are requested to do, for instance, for papers. And there's a lot of reproducible practices in information retrieval research, but sometimes this is limited, of course, in commercial settings or real-world scenarios where it's not so easy to reproduce some algorithmic approaches. So let me pass now to the privacy and data governance, and this is, of course, you have already mentioned some people in the comment and in the first poll of human oversight. Privacy is much related to the system respecting personal data and also not only which personal data we gather from people, but also how we govern it or how we deal with it. So these requirements say that systems should ensure the respect for privacy, implement adequate data governance mechanisms, and also making sure that the data is good quality, is also preserve the integrity, and that only the people that should have access to the data do have access to data. So this has been much discussed, of course, in the context of the General Data Protection Regulation in Europe, and also in the context of research field. There are different related topics to this requirement. One is, for instance, mechanisms for data minimization and anonymization. So when do we really need the identification of the person, or we can just work with maybe with some certain characteristics, then, and which ones are really needed to do our research. And sometimes there is also always the idea of, okay, I get all the data that I need, but we need to think about which data or which personal data do we really need. There have also been some research on privacy preserving algorithms that try to minimize this kind of personal data. And also there have been some ways to document how we collect, label, process, and audit the data. And Elizabeth will mention some transparency approaches for documented, for instance, data sets. As I mentioned, we need to be sure which data, and especially which personal data we need. And also in terms of machine learning models, of course, we need to make sure that the data sets that we use for training our models are relevant, they don't have errors, and they are also representative of different people, which is also some aspect that Marcus will mention in the topic of bias. So there is a paper, and there's not many paper, at least in the music information retrieval field, related to privacy, but I thought this paper was very interesting. I mean, it's more about discussion on the different legal approaches that we have for personal data gathering. There's, for instance, in the EU versus the US, and then those different levels of personal data, some of them leading to the identification of natural persons, the other one just leading to the identification through indirect or complex process. So The challenges, of course, are which data do we need, for instance, for personalization? And we say there is a trade-off between privacy and personalization. Then how to ensure that people are informed and they provide consent to the data they share or personal data they share. Being some of this implicit, is difficult also to provide this information. There's also the discussion about the time dimension, if we need data on a continuous way, and then also how to minimize this personal data. So this is something we should all consider, for instance, when starting a project and also when developing an algorithm, which kind of data do we really need for our research. We also carried out in my team some work on the music domain when we tried to, this was in the context of music emotion recognition, for instance, and then we tried to see the trade-off between personalizing music emotion recognition models to cultural background, to language, and to familiarity with the music. So all those aspects that can help us identify the person. And also how is the trade-off between this personalization and also ethical principles and consent of people. So we experiment with different ideas, and for instance, informing people about why we need to collect different data, and also involving them into annotations with a more transparent way. So this is a work where we have tried to implement some of these principles. So I wanted to know now, I hope it's open. Yeah, if you handle any personal data in your research and maybe in your work, or if you are more dealing with algorithmic systems where there's no personal data involved, maybe it will allow us to see in this community, or at least in the audience, which kind of personal data are you dealing with? Okay. So age and gender are maybe two of the characteristics that has been most studied, and Marcus will also explain, for instance, in the context of fairness. There is a lot of discussion, for instance, about gender and which kind of gender information should we collect, and also how we define or classify gender, because this is a very sensitive characteristics which should be self-declared, and I will cite later an interesting paper on demographic diversity. Age is something that has been also much used. For instance, there's a lot of research dealing with children and how they access, for instance, online services, and how we should adapt to particular ages and needs. Nationality is sometimes related to language, and this is also important in some contexts. Name is just identifying the person and might be also relevant for tagging. And of course, I was sometimes we have more like religion, spiritual, or philosophical belief. This is sometimes that's some information we infer that could be also misused. So we need to consider the need for this data. And finally, nobody mentioned biometrics, but this is one of the biometric identification, such as facial processing and voice, has been much discussed also at the European level, the need for this data and the risks of having access to this data. So of course, there is we see that there is a lot of personal data we infer. Of course, sometimes we don't have the name, but we can easily associate it with name, and we have to consider a good governance for this kind of information. Let me move now to the fourth requirement. Remember, there were 7, so I'm more or less in the middle of this. The fourth requirement is transparency, and my feeling is that transparency is really the crucial one, and that's why we also devoting some time later to that, because the transparency requirements means that we need to make evident which is the mechanism, which are the mechanisms behind the system development. This doesn't mean the models or the system should be explainable, but that we should communicate which is the data that we use, how we develop our system, and which is the business model behind. Business models is often very linked to the accuracy metrics, for instance, that we use to evaluate our systems. The second part of the transparency requirement is that in addition to document data system and business, so that we can trace or we can audit it, we also need to explain to the users or to the impacted people how the system arrived to a certain decision or recommendation or ranking. So this is also related to the way that people might be able to control the system, which is the first requirement, human oversight, but also to the way they might just challenge the system. And finally, in the context, for instance, of generative models, we have seen the need, this requirement relates to the need to inform people that they are interacting with the system and not with a human being. And this is more and more relevant when the state-of-the-art improves the quality of the generated outputs, such as text, audio, or video. This is much related to the recently found or recently started Center for Algorithmic Transparency at the European Commission, where I am a part of. I become part of this center. So related topics, of course, are first we need to document how our systems are built, evaluated, which data do we use for training, and of course, which are the limitations and potential errors that our system can make. This is not very usual when you write a paper to do an error analysis, but in this requirement, this is stressed. Then related topics is the documentation of how should we monitor the system, for instance, which kind of logs or trace should we have, and then how can we just audit it. Then the second is how people can control system, how to interpret the output, how can override the output, and also some aspects such as the life cycle of the system. If how long should the system be used, how to update it or to maintain it in the future, because it might be maybe behaving differently in the long term. And finally, the idea of communicating to users, like how should we communicate to users that this is any assistant, should be put a disclaimer, or should we just introduce that into the interaction with people. This transparency has been a very relevant topic in the context of music and in the context of music generation. For instance, there has been some discussions on the way that this can just confuse people if you give if you give synthetic content that is very realistic, that this can be used to propagate fake news or to impersonate people. And also there has been a lot of discussion in the context of artists and creators about intellectual property of those kind of systems. And we did a study also on that in the context of singing. And there has been there is now with the new models, the recent models for generating images or music, this discussion about, artists and creators generating content that is then used to train on those models. So this is a little bit some particular problems in the case of generation. So I wanted to ask you, maybe which kind of information do you think a user should have about a search engine in order to challenge it? Of course, developers, they have a lot of information about an information retrieval engine. For instance, we know the data we have in our data set, the data we are just the content of and the data set of items that we are using. We also know the algorithm that we are training and also which is the objective function. So we know how the algorithm is shaping. We also know the evaluation metrics we use, but which information from that, from the developer, do you think a user should have and how? So if you can maybe give us some ideas. Okay, the logic used for the provider goals. This is never disclosed, so not very often disclosed, but this is one of the things where people could say, okay, I am checking the, I don't know, most popular, or I'm being recommended the most popular content, or I am being recommended, I don't know, a diversity of content. Yeah, challenge mean that, I mean, the user might, for instance, be able to control the system. So challenge means that if you have the information about how a system works, then you are able to take an informed decision if you want to use it or not. So this is the idea of challenging. How to change the ranking? This is sometimes not provided. Maybe not many search engines allow you to change parameter, for instance, of the ranking system. The features that are used for ranking. This is easy to do for many feature-based algorithms, but sometimes for machine learning algorithms or for end-to-end system, it's difficult to provide some control. So I think you see there are many ways that we can inform the user about our system, and also give ways to control it. So this is a bit the idea of the requirement of transparency, that we can provide information and then we can also control the system. Okay, so the fifth requirement is about diversity, non-discrimination, and fairness. I will not stop here I will not focus here on bias and fairness, because we will have the second part, just talking about that. But of course, there has been a lot of work in this. Maybe there are much work, but there's also a lot of technical work on the field. But I wanted to focus maybe on the one moment on the aspects of diversity, because you may be familiar with some of the diversity initiatives in the information retrieval community. So I wanted to maybe stop a little bit into diversity and explain you a little some examples of work on diversity of information retrieval. Diversity is one of the principles mentioned as well by UNESCO on the need to ensure the promotion of diversity in the development of artificial intelligence systems. This is justified by the need of incorporate the views from different people in terms of aspects such as gender, age, cultural origin, language, or political opinion. And also because it has been found that the more diverse team we have, for instance, in the development of a system, this is connected to creativity, inclusiveness, and also innovation. So I wanted briefly to mention or summarize on two different topics. One is demographic diversity, and the second one is the concept of diversity by design. And demographic diversity is a topic where I have been working for some years now, and motivated by the fact that the people that have been involved in the development of more in general technologies have been mostly biased towards a particular kind of people. And this is an example of a very well-known picture on the founding fathers of artificial intelligence, where we see there is a bias towards white male, and also some well-known statistics for instance, in the industry, where you have a lot of male employees. So there has been, for instance, in the AI Now Institute, also in Stanford AI Index, there have been many policy needs, and also in the research community, many claims about the need for diversity in the field. And this is maybe something that you see in our conference, also in our communities, that we have efforts to increase the diversity of the given community. Let's see a little bit about you and how diverse is this group of people attending to this tutorial. So maybe if you can include here what best describes your affiliation, if it's academia, industry, research center, or public administration. Okay, so we have a distribution between academia. There's most people here in the audience are from academia, but there is a lot of presence of industry. There has been also a trend in the technical community. Whenever we have real world systems and commercial systems, there's more research carried out in industry, and there's less people from, for instance, from research centers. And public administration, there is none. So this reveals a bit the diversity of the research community attending this conference. Is mostly maybe academia. You could do that also for all attendees or for all authors of papers. Maybe another idea, what is your country of the affiliation? The country of affiliation is sometimes reflects the diversity of the funding and also the efforts or that different countries spend into research or into a specific field. So countries of affiliation is sometimes also relevant for diversity because country is related to culture and also is related to language. So in our research, so we see many people from Australia. Of course, so you see a country of affiliation. Sometimes in conference depend on the place of the conference, of course, because people can travel or not, and that's why conference changed their location in different editions. Maybe now we go to the country of origin. This changed a bit from country of affiliation because people might also need to move to other countries to do research, and this is then not related to the amount of funding that each country devotes to research or also the amount of research centers and companies, but also relate to the education and talent. So then we see a more diverse here of number of countries. So you see the difference just between those aspects, but the diversity of country of origin also reflect your cultural background of people, and also this have implicit or this has also an impact on the systems we develop. So you see it's very different from the country of affiliation. Maybe the gender, and here I put some pronouns where people can identify as gender should be always something we declare ourselves. So it's has been a lot of discussion between discussion on the problems of labeling people with gender. It should be more declared. So here we see. I was surprised to see more female attendees, but we see really a balance between genders. This is very nice, but it's not the trend. Usually we have more men than women in the technical fields. And maybe just the age. This is also an idea of, this gives you an idea of who are the people that are doing research, mostly are young people. So sometimes we have a problem also on age diversity. And I don't know if you have heard about the sometimes the gap of technology for old people or for senior people, and this is something that we also have to consider. So we have a very young audience here, and also finally, in terms of research topic, there should sometimes we say the more diversity there are in teams, the more creative is the outcomes of the research field. And sometimes, for instance, in the music information retrieval field, we have people that do more research musicology, people that do research more on really machine learning. So this gives you a little bit the focus of the conference. Here you put Rex's information retrieval, which is of course the focus of this, visual search, this other topic. So you see the variety of there's some people working on fairness, which is as one of the topics, and bias that we will address later, and Marcus will explain about that. E-commerce, so this reflects different applications, explainability, which we will also address. So yeah, these questions are good to know also about your work. And yeah, so I will just very briefly talk to you on a methodology that we have been working for. I have been working for several years on how to really do that in a method, or define a methodology just for demographic diversity of research communities, which has mainly 3 steps, and this is summarized, explained in detail in that paper recently published in IEEE Transactions on Affective Computing, because we did the same analysis that we have informally done with our group for the affective computing research community. And then we, of course, some communities have been trying to increase diversity and trying to set targets, then monitor diversity and then implement diversity initiatives. For instance, in the first step, some communities have been trying to increase the presence of gender diversity. For instance, there are many communities such as the information retrieval or the Rexis community, where this has been groups related to the presence of women. And then other communities have been trying to, for instance, increase diversity in terms of ethnicity or geographical location, institution type, or disability. So we need to consider as a community how diverse the community should be and which kind of dimensions we will want to reinforce. And this should be, of course, a collective decision, but it's sometimes really pushed by those minorities that want to be more present in the community. In our case, we try to monitor. You saw we have. I have done a small survey, but we could do this survey, for instance, when registering to this conference or to Brexit or to CIR, and then have information about people that are attending, authors, keynote speakers, or reviewers. In our case, we did that by extracting information from papers and from websites of conference and trying to automatically label some aspects such as gender or institution type, the ones that we have mentioned. Of course, we didn't have some information such as country of origin, but there's some information you can find on the papers. And we were doing that automatically and then manually. So we could now see a little bit how the community is distributed. We also reviewed the different studies that have been trying to do something similar. For instance, there are different groups that are related to the promotion of women. So you see here gender as one of the aspects they cover in monitoring diversity, but some other studies such as the AI Index report, which is from the US, is trying to cover also sexual orientation, ethnicity, countries, and institutions. So this gives you a little bit the idea of how we can measure diversity in our research community. Diversity indicators are usually based on dual concept diversity. So we measure the variety of categories, for instance, the variety of countries, and then also the presence of each country, so the balance. And this is, I think, this kind of metrics we also use in fairness research. And examples are Shannon, Pielou, Simpson, or Herfindahl-Hirschman indexes. And we can also add a third dimension to account for the similarity among the different categories. For instance, in countries, we could see which is the distance between countries. And then, of course, if we have different dimensions, for instance, gender, geographical origin, and industry versus academia, like institution, we can weight them to have an overall diversity indicator. We collected this for different conferences. This is part of the Diversity in AI website, and you can see, for instance, for Rexis and for I think we have also ISMER, and we are trying to do that now systematically for all Rexis conferences. But we found, of course, limitations in terms of curated data, like for instance, country, gender. It's very difficult to find. You have to infer, and this also is linked with ethical concerns that we have discussed before in the privacy requirement. Of course, then once we have set the diversity targets, we have monitored. There are different organizations and groups that have been trying to increase diversity by implementing different initiatives. For instance, women in information retrieval, women in music information retrieval. And here you have a list of different affinity groups that are trying to increase diversity by implementing some mechanisms such as mentoring programs or funding programs and special sessions. And I tried to look at the program of this conference, but I couldn't find any, but I'm sure there's some initiatives also in this conference. So now maybe you are more aware of how they work and why we need those kind of initiatives. So just to summarize, I wanted to step and stop a little bit on this because I think it's a very important part that and very important aspects because it's linked to all the 7 requirements. If we have more diverse group of people developing those systems, they will have different sensitivities and they will also incorporate different needs and in the field. Although, of course, there are many challenges for doing that. And just to wrap up with the topic of diversity, this same analysis that we have done for demographic diversity, which is a very particular thing, should be done in a way for different aspects of a system. This is an example of the different aspects addressed by the PhD thesis by Lorenzo Porcaro. He assessed the impact of music recommendation diversity on listeners, and these are the different aspects that he was trying to consider with a diversity view. And you have at the left side the item diversity. Of course, we know in information retrieval how relevant are items, and of course, in item diversity you can consider the diversity of the content and the diversity of the source. And all the exercise we have done in this monitoring and ensuring should be applied here. And on the right side, you have, of course, the user diversity, where you need to consider different characteristics of the users, as we have discussed previously. The interaction between the item diversity and the user diversity give us then 2 kinds of diversity. One is the perceived diversity by the users, which is subjective, and we should ask users about it. And the second is the behavioral diversity, which is the result of the interactions between items and users. And this is something we should consider for a more holistic view of diversity in the design of information systems. So I just recommend you, if you are interested in the topic, also to check this work. I will now go to the 6th requirement, which is societal and environmental well-being. This is a very broad requirement, and of course, it has been less research, mostly in our community. And this requirement mentions that AI systems should benefit all human beings, including future generations. So we need to think about the impact and also the future impact. It should be also ensuring environmental and sustainability issues, which is something that is under discussion at the moment, and also societal impact. And I will mention 2 topics that have been discussed and researched in this field. The first one is, what is the impact of systems on jobs and skills? Of course, those systems are providing help to people, for instance, to look for information, but they are also replacing some of the tasks that people do. And we did a report and an analysis on this, but I wanted to ask you, how do you think that information retrieval, recommender systems, or search engines are affecting workspaces, or how they are? Because we sometimes see them as more for entertainment, but I wanted to know if you think they will have an impact on work and jobs of people. Okay, so you think that nobody thinks there is no significant change, so we all agree there is a changes in the work space brought by technology. But of course, these three options, like they are changing jobs, creating new jobs, are replacing entire jobs. This is really the research questions that economists and people working on labor markets are trying to answer. And of course, answers are never yes or no. They are always in the middle. So they fit a bit with the most voted option, which is they are changing jobs. We did this study. I contribute to this study with colleagues who are specialized on. They are social scientists. They also look at the impact on jobs, and we did a mapping here from the left to the tasks that people do. There is some data set of tasks associated to jobs. And then we did a mapping between tasks, for instance, lifting people, or here I put the tasks that are more related to music, because I wanted to give an example on music information retrieval and music generation. For instance, a task should be advise people. And then we map them to cognitive abilities. Those cognitive abilities are defined by psychologists and cognitive scientists. For instance, one is MP is memory processing, VP is visual processing, auditory processing. So these are different cognitive abilities. And then we map the task to the abilities that are needed. And then we map those abilities to some AI benchmarks, such as ImageNet or machine translation and computational tasks, to see a little bit the impact of improving those tasks and what will be the impact on abilities and on tasks. And then we are building this model that allows us to see the impact. Of course, we see the impact when we have data about people, and this is done on a survey with surveys that are not very dynamic. So we are trying to work on that. But of course, there has been a lot of impact of computer vision research on some jobs that require visual processing, and also now there's a lot of discussion of, as you may know, of large language model and the impact they will have on people, like producing text or at least, for instance, writing speech for people or making summaries. So there is no doubt there is an impact, and we need to see which kind of tasks do we want to have, where we want to have people, and in which kind of tasks we want to have systems. So this is an ongoing discussions that will be a matter of research. The other topic I wanted to raise is, of course, the environmental impact of systems. We haven't, in our community or in the technical community, there have been some studies, and they are coming. For instance, we did a small study on the topic of optimization of accuracy versus scalability. In the context of music version identification. This was the work by Furka and Jessler, and then we were trying to use different embedding distillation techniques to have less storage, faster retrieval, and similar accuracy. So this is a work that we see is very important, or this kind of work for the environmental impact of information retrieval system. And also there's some conference, such as 9 conference, that have environmental statements also related to the research and also to the conference business itself. So this is such impact on jobs and impact on environment are maybe the 2 topics I think are most relevant. And the final is a requirement I wanted to mention, and then I wrap up, is accountability, which are mechanisms really to share responsibility of the impact among all people involved in the process. And this is quite complex in algorithmic systems that are very, very complex. They have different components, different models developed by different people. So it's important to know how to audit systems, how to reproduce them, and also how to somehow know where, if there is a problem, where the problem comes from. And maybe some question about challenges you have found to reproduce an algorithmic system or a paper or an approach, which I think should be something we spend a lot of work into into developing, but not into documenting a system. And this is maybe something that my colleague Liz will address in the future. Let me just wait a bit to see some of the. Okay, lack of code, stochastic sampling. Yeah, sometimes we have the code, but the code is not very well documented. It's also open source is not the same than reproducible approaches. Data that might be missing, especially if we want to preserve personal data, we cannot publish it. And also in the music domain, for instance, we cannot publish copyright material. So we have also some limits in the reproducibility. If you have probabilistic methods also, you may have some problems. Okay, so I think there's one person typing, then I will go to the next question. Okay, we move. Okay, so this was a little bit my overview of the 7 requirements. As you know, they are very broad, so it's difficult to get into details. Some of them have a strong background of research, such as technical robustness and safety. Some of them have some research, such as bias or transparency, and some of them are newly addressed, for instance, in this field, such as accountability or societal and environmental well-being. And just a few words about how those ethical guidelines, which are very broad, are now, at least in Europe, merging into or converting into legal requirements. Of course, legal requirements are more precise and more concrete. On the one hand, there is the AI Act, which focuses on AI systems, which are software products. And in the AI Act, according to the different risk levels, there are different requirements. For instance, in the minimal or no risk, there are no requirements. In the transparency, you need to communicate to people, for instance, in chat box, that they are interacting with an AI system, so there are few requirements. For high risk, which are contexts where there is an impact on fundamental rights, for instance, education, job, like recruitment, or also access to social support system, there are some requirements which are here in terms of robustness, human oversight, transparency, documentation, and data. So those kind of 7 requirements are really considered into this regulation. This regulation is still not adopted, so it might change. It's still in the procedure of being drafted. And the second one that is maybe more relevant for this audience is the Digital Services Act, which really address digital first services, which are search engines and online platforms. And according to the size of the platforms, and I put here these layers, like intermediary services, hosting services, online platform, and very large platforms, very large at more than 45 million users, you also have some requirements. And those requirements are related to the risk management. So we need to have a risk assessment to see which might be the risks and define proper mitigation measures. There are some requirements related to transparency, for instance, of recommender systems and online advertisement. There's also some external and independent auditing, internal compliance function, and public accountability. It's notably to mention, for instance, that for very large platforms, there's the need to share data with researchers, and this might open up new possibilities for researchers to carry out studies on very large platforms. And there is also the requirement for cooperation in crisis situation. So this is currently the regulation that is entering into force. So it will be implemented this year, and I am part of the Center of Advances, this Center of Algorithmic Transparency, that is providing more scientific and technical support to the Digital Services Act. So just to finalize this, this is my last slide, although we have been focusing here on the European perspective. Those requirements are also reflected by UNESCO in the ethics of artificial intelligence. And for instance, there is those principle, proportionality and do not harm, which is related to social impact, safety and security, which is related to technical robustness, fairness. So you see, there's a lot of commonalities worldwide on these kind of requirements, although of course legal and regulatory approaches will depend on the country. But just to say that those are currently algorithms that are deployed worldwide, and it's expected that also regulations and ethical requirements will also be global. So this is something we will be looking at forward in the future. So this is a little bit everything from my side. I don't know, Marcus, if we can maybe take some questions now, if there are some questions, or we should maybe wait a little bit. Yeah.
I think if there are questions, we can take them now. And I also think that a break is scheduled to start in like 2 minutes at 8 a.m. our time or 3 p.m. your time. Let's move from organizational talk to the real content. So welcome back. I hope you enjoyed coffee. And now in this second, or actually third part, here we talk a little bit about questions of biases, and in particular undesired biases, and how they affect the fairness, and how all of this relates to discrimination or non-discrimination of algorithmic ranking systems. So after having clarified these things, the main kind of more technical focus, so to say, will be the last two parts here. So how can we measure biases, for instance, related to user demographics or popularity of items, and how can we design strategies to alleviate or mitigate these unwanted biases, and in turn improve the fairness of retrieval and recommender systems. So we've already seen this very nice illustration of the 7 key requirements for trustworthy AI, and I tried to position this part here. Not very surprisingly, it relates to key requirement 5, particularly on the non-discrimination and fairness aspects. Some of the things discussed here also relate to privacy, frankly. So in particular, methods to de-bias, biases that are in the data can be regarded also to some extent to improve the privacy of the system, because, for instance, to kind of unlearn specific protect characteristics that are implicitly encoded in the model, like, for instance, the gender of the user or religious beliefs of the user, the sensitive attributes we've been discussed already. So this should be yellow, at least to some extent as well. So already heard a lot, thanks to Emilia's great talk about different EU regulations, so I'll not dig too deep into that. Already talked about DSA and the regulatory framework for AI, but more fundamentally here, when it comes to discrimination or non-discrimination, it also relates, research also relates to the Charter of Fundamental Rights. I took the freedom here to replicate 2 articles. 21, which exactly targets non-discrimination, so actually and extends also, of course, to algorithmic ranking systems here. So people must not be discriminated or disfavored on grounds of sex, race, color, and so on, ethnic, social origins, genetic features, language, and so on. And in particular, there is also a second article, 23, that particularly focuses on equality between women and men. Yeah, not yet about other diverse genders. I don't know when or whether this will change. But I particularly mentioned specific areas for equality between the genders, so particular employment, work, and pay, of course. And we'll then talk actually next about how these things relate to retrieval and even more to recommender systems. But let's start with a very kind of high-level perspective on biases, to say. And here we can distinguish between societal and statistical biases. So what are those two? Actually, societal biases refers to kind of a mismatch between how we want the ideal world to be, which is already a philosophical question, of course, to some extent, and how the world actually is. So we might want, or I hope most of us, if not all, will agree that that pay for the same job should be the same regardless of gender or other sensitive attributes, or we want an equal representation of for instance, of genders in search results. So if you search for CAO, you might not want to only get information or images about men, or if you search for nurse, which is also a gender neutral term, you might not want to only receive female or images of female nurses or information of female nurses. So this is what societal bias is about. On the other hand, we have statistical biases that relates to how the information or data is encoded in our algorithmic ranking system. So this means discrepancy between the actual world, how it is, and how it is modeled or encoded in the system or the created machine learning model. So very often, a typical example is that the data, for instance, used to train the algorithm is not representative of the population, of the general population. Or another example is that, for instance, depending on the domain or on the platform, on the digital platform, the recommender system is adopted in. The systems attract different kinds of people, which is then referred to as community bias. So if we now, so this was on a very general level, of course, if we now consider which biases are important for information retrieval and recommender systems, the first thing, if you browse the literature, is that you have an exploding number of different kinds of categories of the different biases. So it's really hard to come up with some synergized taxonomy or categorization of biases. So I acknowledge that this is certainly not the only way you can look at biases and categorize biases, but this is the one that I'll be using in this part of the tutorial. So we know, of course, heard this often, that our decisions are strongly influenced by such IR and recommender systems. And this is due to several facts. So the first bias, so to say, that affects, well, actually all of these parts of the system, which are the user, the algorithm, and the presentation of the results on or the delivery to the user. And the first kind of bias is data bias. So very often, as already said, algorithms are trained on unbalanced data sets with respect to an overrepresentation of some majority group, like, for instance, male users on music streaming platform Last.fm, for instance, or also on other social media platforms. So this can be considered a demographic bias, or it's already introduced a community bias. So this data is used to train algorithms. And of course, if the algorithms are fed with unbalanced data, they will also learn unbalanced representations, whatever they might look like. And this might even reinforce certain stereotypes or biases. So one bias we'll also talk about later, which is a result of this, is popularity bias. So kind of, well, other words, this relates to a rich get richer effect. So actually, content that is already popular on the platform will be more frequently recommended to the user, which actually attracts even more interactions. So we start a vicious cycle, actually making already popular content even more popular. Then we have the presentation bias. As already said, this relates to different exposure, different items get because of the way they are presented to the user. So for instance, if you have a ranking, of course, then the user is more likely to interact with the top items, but also with the items at the very bottom. So this is what is referred to as serial position effect. So we remember if you presented a list, we remember best the items at the top and at the bottom of the list. So this is also something to take into account, and this is kind of something that connects to both, of course, the user and the presentation of the items. And this also, well, we don't have the time here. We had another tutorial on psychology-informed recommender systems where we kind of went very much into detail about all of the psychological effects. But of course, psychology and cognition of users in the perception of items is biased by many different things that strongly relate to psychological aspects. So now we know, and I guess we agree, that such systems are prone to different kinds of biases. Not all of these biases are bad, I have to say, but they can be harmful if they result in disparate treatment of different users or groups of users. So this has already been long before actually the evolution or the common adoption of recommender systems. This has already been stated by Friedman and Nissenbaum. That actually means that the system systematically and unfairly discriminates against certain individuals or groups of individuals in favor of others. So important parts here is, of course, the unfair discrimination and that it does it systematically. And this is where things actually become problematic, as they lead to unfair algorithmic system behavior. So I already mentioned, however, that, of course, such unwanted, undesired, harmful biases are really a problem, and we'll talk a lot about that, how to measure and how to mitigate this in the next 40 minutes or so. However, it's also important to note that not all biases are bad. Because a certain amount of biases, if you think about the recommender system, are also important for personalization, right? I mean, without any tailoring of the results to the user preferences, which can also be regarded as a bias, no personalization is possible. So the recommender system has, to some extent, of course, have a bias towards items that the user or that is more likely to consume than other items. Otherwise, the users will probably leave the platform very soon. So that's really a delicate question. So this trade-off between the level of personalization of results the user gets and the level of fairness or bias of the system. So maybe to underline this, a small experiment or case study, if we consider popularity bias. So actually already introduced it, that refers to an overrepresentation of particularly popular content in the retrieval results or recommendation results. So one solution, of course, to get rid of the popularity bias at all would be to recommend all content, or to give all content in the system the same chances to be recommended, or the same likelihood, same probability to be recommended. But consider, for instance, a system like Spotify with 70 million individual songs. If the likelihood for each item to be recommended would be the same on average over all users, then this would mean that a lot of users will receive a lot of very unknown items, also a lot of long tail items they might likely not want to listen to. So this would actually probably harm the business value or the business perspective, the business goals of the platform providers. So this is certainly not what they would want to offer. Then we could also take the perspective of calibration, so popularity calibration in particular. This would mean that actually we want to design a system in which the popularity of the recommended items is about the same as the popularity of items the user already consumed or has already interacted with. This is in fact a common strategy to follow in debiasing recommendations. This could be done on an individual level, of course, but it could also consider the community bias of the system. So the average level of popularity could also try to mimic the average popularity in the interaction history of all users of the system, or it could be a continuum between the two. It's a personalized calibration or system level calibration. So I already briefly touched upon that, but what makes things really complicated is that there is not only a single stakeholder as still considered in the majority of recommender systems research, but there are multiple stakeholders. So it's not only the end user that is involved in the consideration of fairness aspects, but there are many other parties as well. So first and foremost, you will think probably about the producers of content. So musical artists, for instance, or users sharing user-generated videos or messages. Content consumer, of course, the end user typically, and also the providers of the platforms or policymakers, of course, regulators. And they all have different goals and aims. Some of them are in line, some of them are not so much in line. So said, for instance, a platform provider will likely want to maximize their benefits or their economic value, so to say, whereas the content producers typically seek for as much exposure as possible, so being recommended to as many users as possible. Whereas the content consumer is often interested in, or typically interested in, receiving most accurate recommendations that best match their music taste, or maybe also interested in discovering something new, diversifying the recommendations. So the bottom line here is that it is really hard to find a good, or well, even optimal is too much anyways, a good level of popularity in the recommendation results. As already said, this notion of popularity calibration, so matching the popularity of recommendations with the popularity of interactions, is what is often aimed for. And now again, it's time for a Slido. So I'd like to ask you to fill in this one. So have you ever experienced popularity bias when using retrieval systems like search engines or recommender systems? I hope the poll works. Yeah. Well, not very surprisingly. No one said never. No one said always, fortunately, so there is a bit of hope, at least. That most of you often experience popularity bias. Oh yeah, some answer the next question. So which are, now you can blame the recommender systems or search engines for which you experienced particularly often popularity bias. Well, Amazon was already pre-typed by me, I have to admit. Okay. Top rank goes to Spotify. There are a couple of people from Spotify here, so talk to them. Well, it's also quite obvious in the music domain, to say, maybe more than in other domains. Netflix, YouTube, okay. So basically the big names. Good. So now that we actually know and you already experienced different kinds of biases, let's talk about a bit more from a technical side about how we can measure and in turn mitigate biases. We already said that there are a lot of different kinds of biases, and unfortunately, due to the limited time we have here, we cannot talk about a lot of those biases. So this is why I focus here on two kinds of biases: demographic biases that relate to users that are often modeled or measured as discrepancy of the accuracy of recommendations, so the quality of recommendation results between different groups of users, and popularity bias, the second one we already just discussed about. So focusing on user demographic biases, I depicted here a formula which might look a little bit complicated, but is in fact very easy. This is often expressed as some kind of gap or discrepancy between the quality delivered by a recommender system or retrieval system for different user groups. And this is actually exactly what this formula models in a very, well, general way, so to say. So Melchior et al. In the recommender systems context, for instance, proposed this REC gap, so recommendation gap measure, that actually does exactly this. So it actually just measures the average discrepancy of recommendation quality that is measured, or recommendation performance that is measured by some arbitrary metric mu, which can be rank-based, like NDCG or precision recall, or can also, of course, be any other metrics like beyond accuracy metrics, such as diversity or coverage, item coverage in the catalog. And this actually just models the average distance between any pair of groups of users in terms of the performance measure mu. And of course, if we want to have or if we strive for a fair recommender system, then this REC gap should be as close to 0 as possible. So it is set to perform fair if it performs equally good across all groups of users. And actually, to highlight on a real example how this REC gap measure is brought into effect or actually used, what the authors did here is actually investigate a data set from Last.fm, so the music streaming platforms, where users can share or scrobble their listening events. And actually what they investigated here is different collaborative filtering recommender system algorithms and how they behave for different user groups. So here the values here are NDCG values, so normalized discounted cumulative gain, and investigated here what you can see in the blue line, the NDCG of these different recommendation algorithms for different user groups, so for male and female users. And as you can see here, and in particular here in the summary, so this mentions the REC gap. So exactly this discrepancy in terms of NDCG between male and female users. And you can see here that the recommendation accuracy delivered is always better for male users. So in parentheses here you see, well, the favored group, so to say. Okay, and we see that all collaborative filtering algorithms favor the male group. And we'll actually talk about the kind of resampling strategy a little bit later on. So let's then turn to the second example. So we already introduced popularity bias, and to support this with data, Lesotho et al. Provided a simple first analysis in another entertainment domain, in the movie domain, where they just investigated the difference between how often an item is recommended to a user and how often users actually interact with the item according to the training data. And this really dramatically highlights the popularity bias effect here. So here you can see 10 different movies. Sorry, 10 different movies, and the blue chart here actually shows how often users consume the items. So actually, more precisely, this is the number of users that consumed the items. So users, well, it doesn't make a big difference because users typically do not watch movies many times, which is again different in the music domain, for instance. So some of these, or many of these results are dependent on the domain to which recommendations are affected. Anyway, so the blue ones is actually the frequency of item consumption, and the orange and the blue ones are actually the frequency of recommendation of an item. And here we really see a very strong discrepancy. So actually American Beauty is recommended 6 times as often as would be reflected in the listening, in the watching or the interaction profile of the users. So one simple introductory example, we can also, of course, define these things a bit more formally. And this is also what Lisot et al. Did when they proposed the so-called delta metrics, or two sets of metrics, so to say, to investigate popularity bias. One set, well, it's called delta metrics, and the other one, distribution-based metrics. And here the main assumption is that of calibrated recommendations. So these metrics assume that a user wants to achieve, wants to be recommended items of about the same popularity as what they are used to. So we have two components. We have the items in the recommendation list, and we have the items in the training set, so in the user item interactions, the items which we know that the user already interacted with them. So the idea is to kind of have, well, an approximate match between the popularity of items in the history, indicated by H here, capital H, of a particular user, and the popularity of recommendations for the particular users over items Pj. Okay, and popularity, of course, we need some measure. Well, we need some measure of popularity, which can be the number of interactions, commonly over all users, or can also be, of course, a subgroup of users or some other sources. Now, given that framework, so popularity calibration, this is what we aim for. These delta metrics actually just compute different or statistical moments plus the median of the difference in popularity between the items in the history and the items in the recommendation list. So we kind of provide a statistical aggregation of these things, which does not really consider the distribution of those items over popularities. This is what is done using the distribution-based matrix. So for instance, considering popularity distributions or entire popularity distributions over between histories and recommendations entering this match. So commonly KL divergence or Jensen-Shannon distance is used, or also rank-based correlation investigations. So we'll not focus too deeply on the distribution-based metrics here, because it also gets a bit complicated. But I'd like to give you the general formula here for the delta metrics. Again, might look a bit complicated, but it's not, in fact. So what they define as percentage delta xi is actually the relative difference in popularity according to some statistical measure, some statistical moment, typically between all popularities of recommended items and of the history of users. So just the difference in terms of mean, for instance, of mean recommendation popularity and the history. So positive value here would obviously mean that the recommendations have a positive popularity bias. So on average, recommended items are more popular than the items that the user typically consumes. Okay. And this would actually be an indication of miscalibration of the recommender system. Of course, since this is a general function here, this statistical measure can also be something different from the arithmetic mean or the median. So can also be a higher statistical moment, like variance, for instance, which would then measure this discrepancy in terms of diversity, obviously. So how well is the algorithm able to reproduce different levels of diversity according to popularity in the recommendations? So if this is a positive value, then this would mean that the recommended recommendations are even more diverse, covering a wider range of popularities than the items in the user's history. And then we need some aggregation function, of course, because this is computed on the user level. So we found that more stable median over all of them is best suited to represent an accurate, to have an accurate estimator, because there are always some outliers. So we're gonna skip a set as distribution-based metrics. Yeah, basically the idea is to bin the items according to popularity in the history and the recommendations, and then apply set KL divergence or rank-based metrics. But just to give you some ideas about the results and actual popularity bias values in the data set. So here again, music data set of music listening events have been used, again from the music platform Last.fm. And again, different kinds of recommender systems, foremost collaborative filtering systems, in particular these here, have been investigated. And also two baselines, a recommender that would just randomly pick items and a recommender that always recommends in an unpersonalized way the most popular items, which of course, not surprisingly, has highest or creates the highest popularity bias as indicated in here. So remember, positive values mean more popular content is featured. So most recommendation algorithms are prone to popularity bias. And it's also quite interesting to see that in particularly the ones that are known to perform very well in terms of accuracy or utility have a particularly high proneness to popularity bias. So most notably here, the variational autoencoder architecture have been found to outperform many other algorithms, but at the same time is prone to pretty high popularity bias. So here we included actually, and you can find it in the paper, the results for different other statistical moments for variance. It's still okay to interpret. For skewness and kurtosis, it gets really complicated, so we'll not focus on these aspects here. One important aspect, now that we talked about demographic bias and popularity bias, is that these two can also be combined or jointly analyzed here, as you can see here. So since we have, or in the data set, also demographic information, we can also compute the level of popularity bias when you focus only on female or only on male users. And what we see here is that most recommender systems biases is even higher for female users than for male users. So this is just here given as relative to the all column here. Okay. So actually plus means that the bias for female users increases. And this is the case for almost all of the algorithms except for SLIM. So now a question again to you as your audience. Actually, if you consider a recommender system, arbitrary recommender system, would you rather accept positive or negative popularity bias? So would you rather prefer items that are particularly popular, so more popular than what you used to consume, or rather overly unpopular items? Now it would be great if you could take the poll. Okay. There's perfect equilibrium as of now. Okay. I don't care. Good. This is very interesting because this is actually also what we found out in the first study, trying to confront those fancy offline popularity bias metrics with users' perception of popularity. And that's very interesting to see here that the majority vote here goes to, I don't care about the popularity of recommended content. Somehow in line with this study. Good. So in the last part of this part, so to say, I'll briefly talk about how, in particular, unwanted biases, of course, can be mitigated. And actually, there is a lot of literature, of course, that addresses de-biasing or bias mitigation. And you could categorize approaches into three different categories according to where in the recommendation process this de-biasing happens. So probably one of the simplest approaches is pre-processing techniques or strategies. That actually means you alter the data before you feed it into the algorithm for training. So for instance, you would upsample the data items created by the minority group, or drop data points created by the majority group. Then approaches can also be directly integrated into the recommendation algorithm. So some bias regularization term can be used already during training to get rid or to optimize for particular kinds of biases. Or you can use adversarial training, which actually means that you add a second component that tries to predict a certain attribute from the internal representation of a user or an item in the recommender system, and you try to minimize the performance of this adversarial component of this adversarial network in order to make the recommendations fairer. And finally, there are post-processing strategies that actually leave the data untouched, leave the very algorithm untouched, but then only in the end look at what the algorithm outputs and then either filters items, so completely drops items, for instance, from groups that are already overrepresented, which might be problematic, of course, if you just ignore some of the items. Or you can re-rank the lists in the recommendations, the items in the recommendation list, favoring, for instance, items created by underrepresented groups. So included here one example from research for each of these categories, and we'll just very briefly like to touch upon the main ideas of these approaches. So it's a very simple pre-processing strategy. As said, we can just rebalance the data our algorithm is trained on. So for instance, what Melchior et al. Did here is they upsample the data points by female users, because it's well known that more than 2/3 of Last.fm users are male. So there is a quite strong gender bias towards male users. And actually already showed you the results here, but it's now focused on the second set of results, so the resampled approach, which actually did exactly what I just mentioned. So upsample data items, listening events in our case of the minority group, which are female users, up to the same point that we have a 50-50 ratio between male and female data points. And what we see here, that depending on the algorithm, of course, the effect is, well, differently strong, so to say. But for almost all of the algorithms, the rec gap actually narrows, meaning that the NDCG, so the performance of male and female users, are closer together. The problem here with the simple approach, and this is also what you see here, is that this often means that male users receive worse recommendations, and doesn't necessarily mean that female users receive better recommendations, but it really just suppresses the performance for male users. Yeah, which might arguably be also a problem, that you just basically make recommendations worse for one user group, whereas the accuracy stays same for the other user group. And this is some pattern you often find in these simple data rebalancing approaches. So one example, at least a little bit of deep learning here, or of neural networks here in this talk, is an example that Christian Ganhert out presented at last year's SIG-IR, where he actually took a typically well-performing recommender systems approach, which is a multinomial variational autoencoder architecture, and extended it by an adversarial component. So just very high level, actually, how this works. So an autoencoder is composed of an encoder network that in this case takes as input the interactions of a user over all the items. So this is X, and encodes them into some latent, much lower dimensional representation set that the model learns during training. And then you have this other component, the decoder network, that tries to recreate the original encoded vector of item interactions. So this is a multi-hot encoded vector, which is of course very sparse, especially if you consider data item catalogs of several millions of items. Then a typical user will consume only a very, very tiny fraction of all those items, which means that this latent representation can really be strongly compressed. The problem now here is, and this is also what Gan et al. Showed in experiments, that from this latent vector set, you can infer with pretty high accuracy sensitive attributes of the user. So gender in particular. And this is also why this architecture somewhat relates to privacy aspects, as indicated earlier. However, this architecture in general is a quite well-performing recommendation system. So it's definitely worth investigating it. And to make it a bit fairer and also preserve better the privacy of the user, actually what we did here is add another component, an adversarial network, that uses this latent representation set here to predict the sensitive attributes. The sensitive attribute, which we just use a binary indication of gender here. That is also, that is basically one hot encoded. Okay, and now we can model this from a technological perspective as a min-max game, including two components. We have the loss function of the main recommendation task, and we have the loss for the adversary here. Yeah, and spare here the technical details. You can find them all actually all here in the paper, but I just want to present you the results of how this actually works. So the main goal is we want to learn implicit information that is encoded here in this latent representation set. And we can actually achieve this in this architecture. Performance stays equal. There is a lot of discussion needed on that part, but what you can see here is that the accuracy of being able, so of this adversarial network here, of an attacker network really drops considerably from about more than 70% accuracy for predicting the gender to about 60% or even 57%. So, and finally, I'd like to show an example of the re-ranking approach, so post-processing, where actually Ferraro et al. Presented one approach that downranks or content or up content by the majority group, which is actually male artists. Again, last of M data set is used, and the approach is quite simple. It just up or down ranks male content by a fixed number of positions in the recommendation list using again a popular collaborative filtering approach, so ALS. What's quite interesting to see here is to have or to observe the general share of items created by females in the recommendations. And here actually you see that, for instance, 25% of items have been created by female users when using alternative lists where as a recommender. The interesting fact here is that if you have a look at the female artists in the in the whole data set, then this is 23%. And this, of course, raises the obvious question, and this is what I'd like to get your opinion on. If we have such a recommender system where 26% of the items have been created by women, the other way around, 23% of the items have been created by women, and the recommender recommends 26% of female content, so to say, so items created by women. How would you judge the fairness of such a system? Would you say the system favors female creators, male creators, or that the system is fair? And here we usually get quite diverse results. Not this time, it seems. Because of course it also relates here, of course, how you would define fairness. If you adopt a societal bias perspective, so to say, then of course could say we want 50% of items in the recommendation lists created by male and female users. So perfectly equal treatment. Okay. Yeah, also nice to see. We have 40, 40, 20. Or if you want to kind of use as a benchmark the overall percentage of items in your already biased collection of items, of course. But we can discuss about that later, of course, in detail. I think I just proceed here, so to not take too much time from this final part. Yeah, so basically I already told you about this idea, so post-processing, that actually, this can be alleviated to some extent, but just giving less weight to the overrepresented group, and this is exactly, or downrank items from the overrepresented group, and this is exactly what Ferraro et al. Did. Did here, and they downranked male content for a particular number of ranks. They also conducted actually a simulation study showing that basically also doing so also in the long run leads to an increase of exposure for underrepresented content, so female artists in this case. So to wrap up, we have a lot of biases, of course, not only in computer systems, not only in algorithmic ranking systems, but in particular in those, and they have to deal with a lot of different kinds of biases, set algorithmic biases, data exposure bias, ranking bias, and so on. Some of them are good because they enable personalized results, but of course a lot of them are unwanted and might even lead to discrimination of certain users or groups of users. Most research has been done on popularity bias and demographic biases. There are also other kinds of biases, like for instance, personality-based biases or other contextual biases. But we don't have time, unfortunately, to talk about them here. We can mitigate these biases and categorize different approaches into strategies for pre-processing, altering the data, in processing, basically directly integrating it into the algorithm, or post-processing means re-rank or re-weight the output of the recommender system. Yeah, and there are many open questions, of course, still. So for instance, as evidenced here, it's not even clear to which extent users perceive popularity bias or prefer or not so much prefer popularity biases. So a lot of the answers from you also just said, I don't care about popularity bias. This is actually ongoing research that will be presented at GEAR a little bit later on this year. So just summary for the references, and now hand over to Liz to talk about transparency. If there are not any urgent questions in the audience, I don't know, are there any? Happy to take, I don't know, one or two now, or we can just leave it for the end of the tutorial. No, I don't see any hands raised in this limited view of the room I have. So
if anyone has question, can just raise your hand.
Yeah, I can just see parts of the room, only the right side. So, but I don't see any hands raised. Okay, then assume there are no questions. As said, you can always ask them, I assume here or later on. Okay, then thank you.
Okay. Thank you. I'll take over. I hope you can see my slides. Does it work? Okay, great. Then let's go to the last part in our tutorial. We're talking about transparency, a topic that has already been introduced in the beginning of this tutorial. So I will just briefly remind you of give you a motivation and of the regulations that especially the European Union is now putting forward. Then we're discussing categories of transparency, because we can look at transparency from really various angles, from algorithmic transparency to what users understand as transparency. We will discuss in detail explainability, which is, of course, a very related concept. And then we'll also present some recent research in the field of auditing. So like testing algorithms, testing black boxes in order to see whether they are biased or fair, for instance. And then I will outline 2 strategies how to increase transparency in data sets and in algorithms using suitable documentation. The underlying motivation, I think, is quite clear. So in the end, when we have ranking systems such as IR and recommender systems, we are really it's not enough to just present the user a set of lists, a set of results. But in the end, so users would also like to understand how a system came to their decisions. So these systems should be able to explain their decisions. So why are results shown to a user? This is interesting. So is this because of personalization? Is this because of being in a specific demographics and so forth? It's also relevant to explain how the results were retrieved, and this is increasingly important exactly in this cases where we have now regulation in place that ensures that results are not biased and that they are fair for the users. And in the end, so explaining decisions of systems also help the users assess whether to trust the system. And this is really important when you have situations where users take ranking systems in order to make complex decisions, or when the decisions involve sensitive aspects, such as a user's health, for instance. They need to see whether the system is trustworthy or not. And being able to explain how the decision-making process came about really helps increases this trust. There are also other reasons, not only from this user perspective, but from a scientific, from an academic perspective, from a business perspective. A huge reason is we want to be able to reproduce results, especially in our community now. Reproducibility has become an important aim and an important goal, and having explanations, having some kind of transparency in the system facilitates reproducibility, of course. Another reason from a provider perspective is accountability. So we do want to see when there is something that went wrong, when there's something that when results were, for instance, unfair for users, we want to see who is accountable and where in this process were the mistakes that were made. And from a provider perspective, it could also be like that is not necessarily just a social issue, so that you have fairness or biases, but a system could just plainly be wrong in its assessment. So in order to have system diagnostics in place, and in order to also study the performance of a system and maybe performance losses of a system, transparency is definitely very helpful. Yeah, and like it was put in so nicely in the beginning of the tutorial, is transparency is one of the key features of European law. And so providers really need to think about how to increase the transparencies of their system. Also, there is the expression of a fairness principle related to processing of personal data in the Article 8 of the Charter of the Fundamental Rights of the European EU. So users need to be able to understand what kind of personal data is processed while operating a ranking system. This is, of course, challenging, but we will see how well this will turn out in the next years, I would say. In the GDPR, which is the European General Data Protection Regulation, transparency is also an overarching obligation. So compliance with transparency is really key in order to comply with all these policies. I will not go into detail here, but if you want to read more about the European perspective on this, there's a link to a great document at the end of the slide. Yeah, and I think Emilia already mentioned this in the beginning. So we have the Digital Services Act and the Artificial Intelligence Act, where transparency in all of them is really a key requirement. And I think this is maybe important to mention or to repeat again. So for the Digital Services Act from the European Commission, it's very, very explicit when it comes to online platforms and search engines that this is required that they are transparent in terms of what their functioning, the underlying functioning is. However, I think it's important to mention here that the requirements that the European Commission put forward depend on the size of the platform, measured by the numbers of users. So for smaller platforms, this does not apply, but for larger platforms, just naming, I don't know, Facebook or something like this, all of this applies. So transparency is really key. And you have seen this figure already in the presentations of my colleagues. So transparency is one of the requirements for trustworthy AI in this list here. So this is the key requirement number 4. So we have now discussed all the others already on transparency a little bit, but now we are focusing more on this transparency part. Markus has outlined so nicely that fairness and biases are key research topics, and it's crucial to be as fair as possible when you design a system. And in this sense, fairness and transparency are really interrelated and correlated, because it's impossible to have a fair system if the system is completely opaque, because you will not be able to test if the system is fair. So the system could be fair, but it's not possible to test if it's fair. So in order to see whether systems are fair, we need to be clear, how do the algorithms work, what is in the data, how are the stakeholders, the end users, or also maybe the content providers affected by the system. And this is really challenging to test if the systems are not transparent to at least some certain extent. Transparency enables also these audits. Audits are this kind of procedure, and we will see 2 examples of how audits work, where you test like the function of a system. So you test how the system works, and you can also do fairness audits in order to evaluate whether the system creates fair outputs. This could be a simple input-output study. So you put some data set in your black box, if you have a black box, and evaluate the output, and then you have the same data set and remove maybe a sensitive attribute, and again look at the output, and then you compare the differences in outputs. Transparency also helps with user perceptions of fairness. And I found it really curious that many of you have voted, so I don't care about popularity bias, more or less, in systems. But at the same time, maybe there are some perceptions why you go to a particular type of system, and fairness could be one of these issues. And when we have explanations of a system, we could even introduce new behaviors or nudge users towards a specific behavior. So having transparency related to, for instance, fairness regarding to these male-female content producers, as in the example of Markus, we could nudge users to take fair actions, or at least make informed choices about what kind of content they consume. Is it from a minority in the system or not? And with that, I hope I have made a good case for why transparency is such a crucial topic in the field of trustworthy algorithmic ranking systems. Transparency could be looked at from different angles, like I said in the beginning. So we can see transparency as a system property. And when we look at it as a property of the system, we are interested in identifying how a model, how a system works internally. And there we can have three perspectives, three categories, namely algorithmic transparency, I cannot pronounce it, sorry, and decomposability. So in algorithmic transparency, we're very much interested in like looking at the visibility of algorithms themselves. So what kind of models are used there? How do they function? What kind of architectures, if this is a deep learning architecture? In the second category, we are interested like in how does the model, the involved model really function. And in decomposability, we are looking at, or we aim to understand the individual components of a system, because typically in real world systems, so we have several components interacting with each other. So this would be then how we can achieve transparency in the system by looking at the model, by looking at the individual components, and so forth. However, so in the literature, I would say, so transparency is very often discussed along related concepts, namely explainability, interpretability, understandability, and one key term that you always will see in the literature is the concept of black boxes. Because in practice, we have now many black boxes in place where we do not really know so much about the underlying model on the functionality of the model, or the model is so complex that we cannot trace the individual decisions that the model creates. So understandability means that we aim for having an algorithm that makes a decision, and we aim for having these decisions being understandably for those who are affected by this decision. So the question would be, so why was the decision reached based on any given input? And in principle, you see these kind of understandability concepts in contemporary ranking systems. So here on the right of the slide, you see a screenshot of Amazon. So I looked for a book, Modern Information Retrieval. And then on the right side, I get like recommendations, and these recommendations are based on customers who bought this item, also bought that. So classic collaborative filtering. And here the system already gives you a sort of explanation so that you understand why these recommendations were produced based on your action. Because similar customers than you bought also these items. On the left side, you see a picture how a credit score is computed. And you can find out more about by following this URL at the end of the slide. And here the question would be, so why do I get a loan, or will I get a loan, and in what amount of loan could I get? And this is defined by your credit score, and you see that there are 5 factors that contribute to your credit score. So the largest factor is your payment history, so the amount of payments that you have done. Then the amount owed is the second factor. Then the length of your credit history, then whether you have a new credit, and then a credit mix. So what kind of, I don't know, if you have maybe a mortgage and a credit card and so forth. So you know that there are these 5 factors that contribute to the decision why, or what amount of credit you would get. And this is the concept of understandability. So you understand on what factors, on what basis a decision is made. This is in practice not so easy because typically in ranking systems, in IR and recommender systems, we have not just a simple factors that contribute to a decision, but we have typically complex models, complex machine learning models, combinations of deep learning architectures, and and so forth. And all of this is kind of sort of in a black box. So we do not really understand what's in the box. So we have only, like, we know what goes in and we know what goes out. Problem is also for the user perspective, it's really challenging to understand why the output was created. So why is the output relevant from this ranking system, for instance? Could I trust the prediction that the black box has made for me when I do not understand how it computed this decision? And now I have a question for Slido, for you in Slido. And this question is whether you think that it's sufficient that a provider just discloses how the algorithm came to the decision and how a human could reverse the decision. Do you think this is sufficient? And if you think this is sufficient, please give also a brief explanation. And if not, then maybe also you read no and maybe a brief explanation. So is it enough when we have when we have a black box that we say, okay, the black box just is a deep learning architecture and this is sufficient? How to do this? Does this Slido work?
This, by the way, just one remark. If you move on to the next slide, you will see a number of participants, and well, you should at least.
Oh, sorry. No, I don't see anything.
Okay. That's odd.
Do you use? Okay.
Let me just check.
Okay. Ah, no, I see something. Okay. No explanation should at least be actionable. Exactly. Yeah. I mean, so this is kind of would also be my intuition, because just telling that I don't know, a complex machine learning model would be used is not really helpful in the sense that it requires expert knowledge, and actionable in the sense that I should be able to know how to influence the decision. But let's. And this brings me to this topic of explainability. So an explanation should be actionable is a very good transition to how to design for explainability. In the context of recommender systems, so we had this example with this book, this machine learning book, this information retrieval book. I have here another example. So I have here a target user looking for a book on a children's book about Caesar. Then we have a recommendation algorithm, and then I get a results, and as well as recommend items that other users who are similar than me also have viewed at. So the task is that we have a user item pair and that we create an explanation. In this case, it is a natural language explanation. So that's really understandable for the target user to justify why the item is recommended to the user. In a search system, it would be, so I have a target user, and then I have a black box, which is my search algorithm. And then I have searched for CGR in Spain, which was last year in Spain. And I get 191,000 search results. And the first one is the website of CGR. And the explanations, what also Google now offers as a kind of like an add-on to the search results, the so-called search snippets. So this is basically then an explanation of the concepts that have been used in the query terms. So the explanations are in the form of the search snippets. The query terms are highlighted. They are in boldface here. And then we also get this additional information about the search results. So in this case, about CGR. And then, so that is a special interest group on information retrieval. So in the sense, this is a good understanding to explain to the target users why these search results are relevant to the search query by providing this additional information. So why do we need explainability? It's really important in the case where we have user interactions with the system. And this is basically what the main theme is also for all the technology that we in this community develop. So we develop systems in order to have support for the users, or as Emilia has put it in the beginning, so in order to empower users. And also we want to increase the trust in the system and to increase accountability of the system. And like I said previously, so we also want to see whether systems are biased or unfair, whether there's problems with legal requirements, whether there's problems with training data. So all of these issues are kind of tackled by increasing explainability of our systems. Now I have another question, and I hope this works now for you. So we have seen some examples of explanations from the context of e-commerce, but from your perspective, what makes a good explanation? So what are the properties that make an explanation helpful for you? And please use the Slido to add content here. Mm-hmm. Okay, trustworthy. Yeah. Trustworthy is definitely adapted to the user. This is a very good answer, adapted to the users. And this is actually also an open research field, how to do personalized explanations. Depends, who am I? Yeah, this is also the case because it really depends on what kind of stakeholder you are in the process. Are you an end user? Then you want to see what kind of preferences or what kind of properties of you triggered a decision. But maybe if you are a system provider, the explanation would be more related to the functionality of the model. Human interpretable, for sure. Acceptability, yeah, understandable. Very good answers in the end. So you see that when we provide explanations, so we're kind of like tackling a gap so just having the algorithmic decision alone is not enough. So we want to have additional information to communicate to the user why this is relevant. Other properties of good explanations are listed here. Interestingly, I think none of them, maybe comprehensibility, but none of the others were listed. So accuracy is also an important explanation so that it's really as accurate as possible. Consistency, so it would be great that the users get the same explanations if they have same properties. So and stability is related to consistency. Comprehensibility, I think it's related to understandability, what you have also raised. And yeah, how to design good explanations or how to make black box models explainable is also covered very nicely in this book by Christoph Molnar, Interpretable Machine Learning. So you can read more on that. I want to briefly talk also about explainability in recommender systems, because this is on the one hand also my research field, and on the other hand, I think very relevant for this community here. There is a seminal work on designing explanations for recommender systems in the Rexis handbook by Tintereff and Mastov. And they define explainability, or the aim of explainability in Rexis, to make clear by giving a detailed description. And there we can see that informativeness is a huge goal in order to create these explanations. A second definition is from Foundations and Trends in IR by Sang et al. Explainable recommendation to answer the question of why. So again, so this concept of providing additional information is covered in this definition as well. Tinteref more or less see it as giving complementary information to a decision, so this reasoning, and Sang et al. See it as this explaining this why. More the aim is here to ensure this fairness or achieve fairness through explanations regarding, for instance, protected attributes such as users' demographics. So why was the recommendation produced? Because of your gender, because of your age, because of your location. The question is really how to act upon them if you have this information. And this is also a challenging task, how to leverage this. And this, I think, translates back to this kind of questions of legal and policy domains. Tinteref et al. Also define 7 goals of explanations for recommender systems, namely efficiency, effectiveness, transparency, trust, scrutability, persuasiveness, and satisfaction. And in a work by Ashfar and also Markus, a recent work where they discussed explainability in music recommender systems, these goals of recommender systems have been linked to more general explainability goals in machine learning. So for XI, explainable AI. And when we look at these goals for explainability on the left side by Tinteref et al., we see that they are very much related, again, to this informativeness concept. So like the aim is to help users make good decisions, explain how the system works, increase the confidence in the system. At the same time, we also see persuasiveness as kind of a goal for explanations in recommender systems. And this could be seen as kind of contradictory, of course, because a transparent system should maybe not convince users to try or buy an item. And this is also not really encoded in this XI aims for provided by or defined by Arietta et al. All of this, what they both have in common is it's really crucial to define what the explanation task is. What is the problem? So when is an explanation needed? And you could look at this as a kind of incompleteness problem. So what we want to do is we want to fill in the missing piece. And whenever you have a missing piece that needs to be filled in, it justifies the use of an explanation system. So when the decision alone is not enough for the user to trust the system, to understand the system, so when just maybe a number or a list of results is not enough, then it's always a good idea to add an explanation component that really explains to the users why a certain decision was made. Also in the same work by Ashfar, they define notations for explainable AI. And this starts with we have here above a machine learning system that is trained in order to, so you have some data that is used to train a model, and then the model makes a prediction for some kind of target audience. And now we can introduce an explanation component at various stages here. So we can have here, so let's say our target audience, so we want to increase the understandability of our prediction, and then we can either create data-focused explanations, so that explains particularities from the data. We can create model-focused explanations. And if we distinguish data-focused explanation, so we have to be clear, so what is the scope of the explanation? Is it a global scope or is it a local scope? A local scope would mean, so we explain a specific user item pair to a specific user, while in a global scope, so we would explain more on a global perspective. Then on the model, is the model a black box? So if not, can we explain the model itself, or do we need to apply some post hoc approach? And for the prediction, the question is whether we have some target explanations that are associated with some ground truth prediction. And if we have that, we can do follow a supervised strategy, if not an unsupervised strategy. And for the target audience, we have to be clear about what type of incompleteness, so what kind of missing piece are we trying to fill in? Is it informativeness? Do we want to increase fairness? Do we want to enhance, or do we want to create causality? Do we want to enhance interactivity, and so forth? So in order to design an explanation model, an explainable AI model, so we have to make sure, so in what kind of path are we in our system, in our approach. And here I have just a couple of examples, but maybe I will just skip them quickly because we only have 10 minutes left for our tutorial. I think I've explained local versus global explanations already. So in local, we explain single predictions for user, and in global, we explain the overall model logic. And of course, if we want to see whether our system is biased, then we have to follow a global strategy. Intrinsic versus post hoc. So for having intrinsic explainability, we can explain the model itself. And this is also called white box model. And yeah, there are many algorithms approaches that function kind of as a white box model. So for instance, an item KNN model. So we recommend you an artist because it's similar to another list of artists. And in post hoc strategies, we need to apply some external techniques to create interpretability because we typically have then a black box where we don't know exactly the internal functionality of the algorithm. And this could be, we recommend you an artist because it has some features that you might like, because you have liked artists with similar features in the past. Model versus data. So we can either explain the model itself and the parameters. This could really be beneficial, again, in the case of fairness, because we can then leverage this in order to introduce new regularization techniques, for instance, in order to balance fairness and accuracy. And for the data, we can explain data characteristics in order to see maybe unbalanced properties in the data set. In order to generate explanations, we can distinguish between 3 types. So it could be a feature-based explanation. So for instance, you take a feature of a piece of music and include it in your explanation. We can have an example-based explanation. So your decision is based on I don't know, Pink Floyd, The Doors, and Tangerine Dream. So 3 different examples that are similar to your current outcome. And we can also have knowledge graph-based explanations, which are, of course, more detailed and but also more complex to elicit from data. There are many resources for this topic of how to introduce explainability in ranking system. I list here a few of them, and also the Rex's handbook has a brand new chapter on explaining single item recommendations. But I want to just briefly at least touch upon the concept of auditing, traceability and auditing, because this is an area that receives now increased attention in various communities. So on the one hand, in the more user-centric communities, but also in the machine learning communities. And the idea is that we want to audit algorithms for biased and discriminatory behavior. And this is not only a research idea, but this is also something that is really will become more and more necessary because of all these policies that have been introduced in order to ensure that there is alignment of systems with laws, with regulations, and with ethics. The underlying principle of these kind of algorithmic auditing techniques is inspired by audits in different domains, such as finance, security, employment. So whenever you have, maybe you have experience with going through grant audits. So when you have gotten a research grant, sometimes you also have audits where you have to really be able to have evidence for all the money that you have spent and so forth. So this is kind of similar. So to have some third-party external experts that test the function of the algorithm, if it's biased, if there is kind of discrimination or so forth. And there is a good paper here that showed that auditing helps uncover bias in search engines, housing, hiring, e-commerce, and other use cases. So I would point you to this paper here published and presented also. I don't remember the conference now, but there's a preprint available on the archive. This is linked here. I would briefly mention this example here. So this is a work by Hanak et al. And what they did is, so they audited e-commerce sites for discrimination and price steering. So it was a hotel booking website, as you can see here on the left, and they wanted to see whether there are inconsistent prices depending on what kind of system the user used to log into the system, and other user properties, user demographic properties, region, from what the user logged into the system, and so forth. And what they did is, so they scraped data and then used Amazon Mechanical Turk users as testers to audit these e-commerce sites. And each of these test users, of course, had different properties. And in this paper, they really could show that there's price discrimination for different types of users. And yeah, so you can also, so what the result also of this study was like, so this was not just one study, but this was then repeated on various platforms. And if you go to this link provided here on the slide, you see many of the use cases where they showed that actually there is a lot of discrimination going on based on user demographics in many systems. And this is what like only algorithmic auditing can uncover, because of course system providers are not transparent and upfront about these issues. There are different types of how to do algorithmic auditing. So we can have code audits, so where you look at the system design, at the codes. You can have non-invasive user audits, where you just ask the users in the form of service, or you can have these scraping audits, like in the example before, where you send then repeated queries to test the behavior of the system under a variety of conditions. In this case, it was a variety of user demographics. You can also have sock puppet audits, where you create fake accounts having these properties to study how the system behaves. And of course, crowdsourced and collaborative audits, where you hire crowd workers as testers. And it means, so the caveat of this, so some of these are of course not in line with the terms of services of the providers. So scraping audits, sock puppet audits, and these crowdsourced audits are also sometimes not allowed in the sense that you're violating the terms of services. And also in this study before, so I think they violated the terms of services of the platform that they investigated. Problems is that with these audits is that they require a level of technical expertise that might not always be there. So this is why they frequently have some NGOs like Algorithm Watch doing these audits. So they hire experts to understand also about the particularities of the system, but is of course challenging. Also, sometimes harmful behavior is hard to detect outside of situated contexts. And when you're working with crowd workers, they might not represent the demographics of your system. So you could still have some biases that are undetected. Same when you just work with experts, so you might miss harmful behavior. And this is why in a recent example that was presented last year at the CHI conference, the researchers presented an idea of this concept called everyday algorithmic auditing, where you have everyday users detecting system behavior that is problematic. And so they just had everyday users testing various systems, and then they looked at what strategies these users apply when they do these audits. So they have some inspiration for the search, they do some sense making. There are some folk theories of algorithms, so how algorithms should function or do not function. And then users have employed different strategies how to find problematic behavior. And here are just some examples of this everyday algorithm auditing. And maybe one example, this is maybe that you know it. So in Google image search, for instance, so you had researchers looking for black girls on Google. So this the keywords black girls, and they found that the results were primarily associated with pornography. So this is a kind of everyday auditing algorithm strategy that was employed there. And in this paper, you see several of these examples, but in the interest of time, I will not go into detail here. And maybe 30 seconds. So in order to increase transparency, you should also be thinking about how to increase transparency of about the data sets and about the algorithms that you employ. And in order to achieve this, researchers have introduced the so-called data sheets for data sets, where you have a structured documentation of the data sets that you use to train and evaluate machine learning models, where you document the creation process of the data set, where you document potential sources for bias, where you document why the data set was created, who created it, for what purpose, and so forth. So this is a good strategy in order to document particularities about data sets beyond just statistics of the data. And similarly, also researchers have developed model cards in order to document details about the model. So who created it, in what version, what kind of data was it trained on, what is the intended use, on what metrics it has been evaluated, and so forth, or whether there are any kind of imbalanced issues in the data sets, and so forth. And this has the same purpose. So the idea is really to be upfront with any issues that this model could have, so that researchers can really be responsible when they're working with the data set and with the models. I have here a slide up, but yes, maybe we go over it. We should just skip it. So the question is whether you have used with data sheets or models cards. If not, then I would recommend you that you're working it, especially when you put out your own data set. And yeah, with that, I would.
Each of us 30 seconds. We've already talked about challenges. Anyways, maybe you just keep on screen sharing this.
Of course, yeah, of course.
Yeah, just show everything, I would say. I mean, there are a lot of open challenges, of course, and we could talk that for 30 minutes, I guess. But just to summarize the ones we see from about the fairness part, of course, it's about which technology do we need to debias data, to debias algorithms. Briefly touched upon the different stakeholders. So how should their different goals be considered by the algorithm, and to which extent, of course, and whose stakeholders should be considered. Also, there's a fundamental question of how those computational bias measures of popularity bias, for instance, but also biases how are they really perceived by users and also by other stakeholders? So as we've seen here, a lot of people don't care about popularity bias, for instance, maybe not even realize the existence of popularity bias in recommendation lists, which is also in line by some early study that we ran. And of course, what are the consequences? We talked a lot about socio-technical systems, of course, a lot of stakeholders, and this directly relates, of course, to the question what the consequences of biases, of unfair algorithms are. Of course, in high-risk areas, this is particularly important, like healthcare recruitment, military, and so on. But it's also important, as we've seen in more, I don't know, softer areas, so to say, like entertainment domains, music, movie, and so on, because it also has a lot of consequences, and also what are legal implications. So could you move on to the next one? I think that's anyways yours. Liz, you want to say? Oh,
I'm muted, sorry. I was muted, sorry. Yeah, in terms of transparency, the question is really what level of transparency is useful in order not to avoid to overburden the user with too much additional information to what they already are looking for, but at the same time to not be too superficial. So, and there are different stakeholders. So and I think somebody asked it in the slider, who am I depends. And exactly, this is a very good point. Also, it's interesting to study what the relationship is between explanation and perceived fairness. So the topic of perceptions of bias and fairness is really exciting and underexplored. And I'm also curious to see whether explanations will help with, or what effect they will have on the perceived fairness of users. Then, yeah, we also have to research what kind of explanation types are meaningful for different tasks and different domains. And also at the same time, what do explanations tell us about the user? And this could lead then again to a lot of issues related to ethical and privacy implications, because if the explanation then tells us about, yeah, this recommendation, for instance, was created because of your age and age and gender, then maybe this is very sensitive information that the user does not want to see, like in an explanation on a web screen. So the question how to do this in an ethically sensible way is also an open research topic. Emilia?
Okay, maybe good. Yeah, some challenges that I wanted to put more on generally on social impact. Of course, we have to set a little bit methodologies and targets for social impact and all the aspects that have been discussed, such as fairness, diversity, or impact of jobs. Then I think that this is very important to research on the impact that the systems we develop have on people in the short term, but also in the long term, trying to maybe maximize opportunities while minimizing risks. And finally, I think a relevant topic of discussion also in line with the Digital Services Act, the upcoming regulation that has been mentioned also, is the idea of accessing the data and the behavioral data linked to the systems in order to carry out evaluations and accessing also systems that are deployed or used by many people to trying to assess those and study those different problems such as fairness, transparency, and also social impact and environmental impact. So I think that was all from my.
Do you think there are any open challenges that we missed?
Mm-hmm. It would be great if you could also tell us what you think are open challenges that.
Because our view is, of course, a biased one and a subjective one. Coming back to the points.
Very good. Gap between academic work and real world. Reasonable evaluation metrics. Balance between objective.
Yeah, subjectivity, I assume. Yeah, the gap between academic world and real world. I wouldn't call it real world.
No, but there is I think interesting this balance between objectives, because, you know, personalization versus privacy, you know, there is always this trade-off between accuracy and also maybe explainability. So it's difficult to fulfill all the different objectives, of course, but we need to be maybe also transparent in the objectives we are trying to fulfill.
Yeah, and this fairness under unawareness of sensitive attributes, this is actually really a huge topic, because at least in the European Union, you are not allowed to store sensitive attributes and to provide access to these sensitive attributes. For instance, if you have a minority in some European country, you're not allowed to store who belongs to this kind of minority, but at the same time, these people could suffer from discrimination. And I think one strategy, at least in the European Union, is to develop independent bodies that help then the individual trace these issues related to fairness or related to biases. Yeah? So this is then really a very individualistic approach, not necessarily something that can be solved using, for instance, an off-the-shelf algorithmic auditing tool. Very good points. Yeah. Anything else that you want to add, Marcus, Emilia?
No, when reading this, I was just thinking of the problem, because a lot of us would collaborate with lawyers or legal researchers, of course, and then a problem often in litigation from user perspective is, of course, that to prove to have been discriminated by a system in the setting of recommender systems is particularly problematic, because you don't know what you're not being recommended, right? So if you're only recommended lower paying jobs, you don't know which other, you might not even be aware of that. And this is why these studies, for instance, that have been mentioned are particularly important. So it's really hard for an individual to prove that they have been disfavored. So, sorry, Emilia, you wanted to add?
No, there are two questions in the Slido. One is, could you say more about the difference between deliberate and adversarial perspective? This was one question.
What was the first one? Between what and adversarial?
Deliberate and adversarial perspective. I think it was part of your slides, Elizabeth, no? Or that part? And the other question was about online advertising. Companies are paying to create bias. What can be done to avoid abuses without killing the advertising industry? Maybe that goes a bit for Marcos for the for the.
I mean, I think meanwhile companies are even required to highlight content that has been upranked as a result of advertisement, of basically companies paying money to Google and other search engines and recommendation systems. So I'm not an expert on the legal backbone, so to say, of this, but I'm pretty sure there is one, because otherwise they would probably not tell their users. Yeah. So here, in particular, transparency is even more important. And I'm sure it will not kill marketing or
no. And this is really
not at all.
Yeah. And this is one of the applications that is explicitly mentioned, at least on the European side. Yeah. Now, I mean, in the end, so I think businesses have always been very creative in finding new ways to design marketing. Also under these constraints, I'm pretty sure this will not kill marketing. Okay.
Okay, thank you for that great tutorial. Is there any Oh, yeah. Is there any other
Oh,
question
thanks.
from the audience?
We cannot hear the applause, but we appreciate it a lot. Or at least I couldn't hear it, but we appreciate it a lot. Thank you. Sorry for taking slightly longer than anticipated. I hope you nevertheless found it interesting and can now head to whatever is on the program. And we wish you all a very, very nice wisdom conference. Again, we're all sad that we couldn't attend.
Thank you very much. I think we are all good here.
Great.
Thank you.
Thank you. Thanks for your
Bye-bye.
attention. Enjoy the conference. And please get in touch if you have questions.